Greetings, everybody, from Williamsburg, Brooklyn. The timing of this event was actually just a little bit off. As you can see, I'm rocking like my full quarantine hair here, and I don't have it scheduled to get chopped off until Wednesday. So I'm like one day too late on that. But anyway, today I wanted to talk about our journey to InfluxDB 2.0. So let me give you a preview of what's coming in the talk. So I'm going to start first with a little bit of history and review. We'll get through that pretty quickly. I just want to give some historical context for what we've done so far and where we're going, which kind of frames where we are with 2.0 and why we're developing 2.0. I also briefly wanted to talk about our journey to what I'm calling a cloud-first delivery model, which is a very big transition for us. Then we'll get into what's left. What do we have to do to finally finish up getting InfluxDB 2.0 open source out to be generally available? And then we'll close out with what we're looking at after InfluxDB 2.0. Okay, so to start off, why have we been developing 2.0 in the first place? Well, to know the answer to that question, we actually have to take a look at the historical context, which is looking at the tick stack, which is the set of components that we developed for working with time series data. So obviously you have InfluxDB, which was the first part of the stack that we launched the prototype of in November of 2013. It has a query language that looks kind of like SQL that you probably all know, called InfluxQL. The next thing we launched, which was in June of 2015, is Telegraph, which is our data collector. And from the early days, like from the very beginning of Telegraph as a project, it was a design goal to have it structured so that external contributors could come in and contribute plugins, both input plugins and output plugins, that would just make it easier for people to add plugins to Telegraph to get the data that they think is important into InfluxDB. And because of that, we have hundreds of plugins, most of which have been contributed by the community. So for those of you who've contributed, thank you very much. So the next part of the stack was Capacitor. We launched, I think, the alpha of Capacitor in September of 2015. This was built primarily by Nathaniel Cook. And part of Capacitor was a new language. So Capacitor is our project for doing ETL and processing and monitoring and alerting. And for that, Nathaniel and I came up basically with a new language for defining those tasks, and it's called TickScript. And it looks like this. Now, one of the original goals we had with TickScript was to create it like a functional style language. I had this theory at the time, actually I had this theory in basically the fall of 2014, that a functional style language would be a bit better way of working with time series data than declarative language like SQL. So TickScript was basically our first crack at doing something like that. And the thing is, TickScript was actually really powerful. You could do things in TickScript that you couldn't do in InfluxQL. We'll come back to that in a second. So finally, in the fall of 2016, we rebooted our user interface, Chronograph, and it became basically what it is today. And that's a UI for not just dashboarding or visualization, but also managing the parts of the platform and ideally make it just easier to use if you don't want to use the APIs. So the thing about those three different components and the sequencing of how they came out, they're basically like an artifact of how the company was built over time, right? We had the prototype of the DB in 2013. In 2014, I went out and I basically raised venture capital. I raised our Series A round of funding, which closed in November of 2014. And the pitch at that time was that we wanted to build an entire platform for working with time series data. We wanted to make it easy for developers and builders to create applications for which time series data was a useful abstraction. So basically, after I closed that round, I was able to hire teams for these individual components, and those pieces of software, while integrated together, were actually quite different from each other. They each had a totally different API that was fairly different across each of the, particularly chronograph, capacitor, and InfluxDB. And they almost each had a different kind of philosophy. Chronograph, like I said, was centered around community contribution, or Telegraph rather. Chronograph was supposed to be like a turnkey solution for end users, and capacitor was basically like an advanced solution for operators and people who are comfortable getting familiar with tick script. And then Influx in the center tied all of this together. So the other thing about that time is we were constantly getting feature requests to add new functionality to the database, specifically through InfluxQL. And these started coming in basically from the first day that I gave a talk about InfluxDB. And we wanted to address these things, but for one reason or another, they just remained open for years. So the things I'm talking about specifically are things like mathematics across measurements, the ability to use the distinct function on tags, supporting different ways to slice and dice your data in terms of time, month and year as a duration, date parts, basically saying, I want to pull back, 8 a.m. to 5 p.m. BST for Monday through Friday. Different orderings of your data and limiting the number of series that you're pulling back. Support for a halving clause so you can filter after a group by. And basically we ended up just aggregating these requests into this single issue. And there must be 50 different requests for different pieces of functionality. And the thing is at where we were at the time, there were basically two reasons that we found that we couldn't address these feature requests. One was basically limitations in the core engine that we had created. And the other was, for many of these things, we couldn't figure out how to add that functionality to the query language and still have the query language make sense syntactically and work. So what we ended up with was InfluxQL and then also tick script. So unfortunately, we had two languages for the platform. One for doing interactive batch queries, and then the other for doing background processing. So it created an experience that was kind of disjoint. And unfortunately, it made people learn two different things. So InfluxDB 2.0 is really about unifying the stack. And in particular, it's about unifying chronograph, capacitor, and Influx into one cohesive whole. When you have one API that's consistent across them, and you have a user interface that ties it all together. Now I say unifying the stack, but it's not really the entire stack. Telegraph continues to live on as its own separate project because it's a data collector. It needs to be much lighter weight. But with 2.0, Telegraph is getting connected to the database in more interesting ways. InfluxDB can host configurations for Telegraph, and we're going to be introducing more and more functionality for users to be able to manage and control their Telegraph instances from InfluxDB. So you'll see a much better integration between those components. So as we were going through developing 2.0, here's kind of how we thought about the work sequencing, about what we were doing. So the first thing obviously is make the thing work. So that phase lasted quite a while. Then make it flexible and make it powerful. And for 2.0, this meant primarily the work we're doing on Flux. Then make it fast, and finally make it easy. Now this is all a little bit different than InfluxDB 1, the prototype of InfluxDB, where easy was the goal from day one. But again, what we found with doing that is that the really hard things that we want to make possible in the database, we were just limited by decisions that we had made back then. So we didn't want to have that same problem. So making InfluxDB 2.0 flexible and powerful happens through Flux, which is our new scripting and query language. I say it's a scripting language because it is intended to be a full Turing-complete language where you can express complex logic and arbitrary logic in it. It's not just a declarative query language. However, part of it is also a query processor, a query planner, and an optimizer. So with Flux today, all of those issues that I said that we've been trying to address for years, all of those are possible today, and actually much, much more. One of the things that I'm actually really excited about with Flux is that we, after initially introducing it, pretty soon we realized that a good goal for the project, Flux as a language, would be they shouldn't be tied necessarily just to InfluxDB. We wanted to be able to pull in data from many different sources. So today you can pull in data from Flux, from Postgres, from MySQL, Snowflake. BigQuery is on the way. I think that's in a PR and landing soon. JSON and CSV files on S3, or really any other source that you can connect to via HTTP. And you can pull that data in at query time and merge and join it with your time series data, or you can pull that data in and decide to monitor an alert on it or write time series data back into InfluxDB. So that's the other piece of this, is that we want you to be able to get data out using Flux. Now, the first obvious data sync that you would want to send to is InfluxDB. You do some processing, you do some ETL on your data, and you send it back into InfluxDB. But you can also send it through HTTP posts. You can send data out to Postgres, to MySQL, again, Snowflake. You can also connect to alerting systems and third-party systems like PagerDuty, Slack, and all sorts of other ones, Discord. So the thing about InfluxDB, the thing to notice from all of that is that it really isn't just a database. It's a platform for working with time series data. It's not just about storage and query, but it's also about processing data in the background, connecting to other sources, and merging all of this together to bring intelligence to your time series data. It ties it together with a common language and a common runtime with a set of tools that give you visibility into what's happening and hopefully make it easy for you to troubleshoot if anything goes wrong. So here's what the architecture of InfluxDB 2.0 looks like, or at least the way we think about it. So at the top, you have basically the edge, which is generally where you have data collection and queries and stuff like that. Obviously, Telegraph, client libraries, InfluxDB open source. Part of our vision is to have that operating at the edge. And then other systems like Prometheus and other things. James Governor.
Sorry about that. I just realized I wasn't on mute. I was worried about noise from my son downstairs, and it turns out that I'm the noise.
No worries. Good to have you here. So one thing that's interesting, I think, about this diagram is that these components in red, the other third-party components, these are often unidirectional components, where you're either just sending data or you're retrieving data and querying it out. But many of the InfluxDB components in our stack are designed to be bidirectional. They're designed to push data in, they're designed to query it out, and more importantly, ideally putting in configuration for how other components in the stack run. So this could be like collection rules, it could be background processing, monitoring and alerting, rules for collecting and processing data at the edge, data enrichment, downsampling, and all that kind of stuff. And then at the core of this, you have the API, right? And I have this InfluxDB API thing circled at the center. I just call it that because the truth is it could be another open source instance, it could be our cloud product, or it could be anything really that implements that same API. So the idea is that API is entirely open source, and obviously open source InfluxDB is one implementation of that API. So let's talk about where we are now in terms of getting 2.0 out the door. So right now, beta 12 of 2.0 is out. That's the most current beta that we have. We released Alpha 1 in January of last year. We released beta 1 in January of this year. So we had an alpha that lasted about a year, and we're currently in beta. So this is a pretty long development cycle for us. We also have our cloud product, which is basically another implementation of that InfluxDB 2.0 API. We launched the AWS service in September of last year as a production-ready service. that we were willing to sign up customers for and stand behind and say that we're not going to lose your data, and the system is ready to go. We launched it into GCP in production in February. Right now, we have it in beta in Azure with a production launch in Azure next month. So one question I've heard from people is, how can you have a cloud product for 2.0 in general availability as a production ready service, but the open source product, initially was in alpha and now it's still in beta? Because typically with open source business models and open source companies, what you usually see is the open source is a production ready thing, and then after some number of years, the company releases a cloud service, which is really just the open source thing wrapped up. So this is part of our journey to what I call cloud first delivery model, which I think is interesting, particularly with an open source company. This was a really big move that we had for 2.0. With InfluxDB 1.x and its related cloud product, that operated more like a traditional enterprise software business. We would ship updates to InfluxDB basically 2 to 4 times a year. And then our cloud product was basically just our InfluxDB 1.x enterprise product wrapped up with some monitoring, backup, and other operational controls to scale it up or down within the service that we were running in, which is only AWS for the 1.x product. So what that means is we really only got to ship a feature-bearing release. We only got to ship software a few times a year. And for those of you who have worked in cloud-delivered applications, like the idea of only being able to ship your software a few times a year is horrible. So with 2.0, we wanted to get to a place where the cloud represented our absolute best edition of the product, and we could have something that we were able to ship multiple times per week. So the thing about the cloud first delivery model is it enables things that you don't have in an enterprise model, right? We can upgrade in place with no downtime, with no user facing downtime. We can build stuff for that. We can put in additional backup systems that just aren't possible in open source. We have backup systems in our cloud product. They're completely out of band of the normal storage code path. We can run multiple API versions at the same time, much easier. We can run multiple Flux versions much easier than we can in a single process open source thing. We're able to migrate customer data if a migration is required, and we're able to see which customers are using which parts, so we actually know which migrations are actually required. And overall, we just get better operational visibility into what's going on with the underlying code and what kind of improvements we can make. And we can deploy improvements, like I said, on a day-to-day basis. So this is a rough look at what a single cluster of InfluxDB 2.0 looks like in our cloud product. And it's basically like this diagram is essentially, it shows a bunch of services that run on top of Kubernetes, on top of whichever cloud provider we're running in. And as you can see, this looks nothing like either our open source InfluxDB or Enterprise 1.x. It's basically a platform that is comprised of a number of different services, which can each be deployed and scaled independently of each other. So one thing I think it's worth pointing out is, like I said, here off to the right, you see that S3 line protocol backup. This is one of the backup systems I was talking about. We have a totally out-of-band backup that uses cloud service, whatever cloud service provider's native services they have to use their object storage and their streaming platform so that we can actually back up customer line protocol data as it's fed into the system. That way, if we have any sort of bugs or issues on our code paths in our storage, we have another way to back up that data. We actually have multiple ways that we're backing up data in the cloud service just to guarantee that we don't have data loss. And things like the query tier, those can be scaled independently from the storage tier, which can be scaled independently from these different pieces. And the other thing you can see is that we're using other pieces of open source software to bring all of this together. There we see we have etcd, we have Redis, we have Kafka, we have Vault. So it's basically a completely different product than the actual open source. And one of the big goals with the 2.0 cloud product was we wanted to be able to deliver in multiple regions, but we also wanted to be able to deliver in multiple clouds. With the 1.x cloud product, we were only ever available in AWS. With 2.0, we're already available in all 3 clouds. And to do all of that, that meant we needed extensive tooling. So this is a look at what our continuous integration, continuous delivery pipeline looks like. So at the very top, you have our Git repo, which goes into the CI testing, which then gets deployed into our acceptance environment. We have a different acceptance environment for each cloud provider because we're using different services in each. So we have to ensure that in each provider, things work as expected. That all gets deployed into a cluster we call tools. Tools is basically just an InfluxDB Cloud 2.0 cluster that's dedicated for our own use. And that's basically our internal production cluster. We use that to monitor and get visibility into all of the things that are happening across our 2.0 cloud clusters. So it actually operates at a decent scale today. And then after that, it gets deployed into the different cloud providers. Now, this entire pipeline is managed automatically by Argo. So we just have it, everything just happens automatically once people open up pull requests to try and merge stuff into master. So this is basically what the CI workflow looks like. Going over all of this is actually outside the scope of this talk, but from this you can see it's a fairly complicated process with many, many steps along the way to deploy code from a developer branch into the production system. Now, all of this is to say that we've done a lot of work behind the scenes to shift our development process to deliver cloud first, and then to deliver open source out of that stuff. Now, the truth is, our cloud product is using all of our open source bits. We're using all of those libraries, right? The Flux libraries are the same. The underlying storage libraries are the same. The API libraries are the same. All these different pieces, we're just bringing them together in a different configuration in our cloud service. So to do that, we had to build all of this tooling. But what that means is we built all this stuff so that we can be sure that we can run this cloud product in production, even though our open source is actually still in beta. The thing is, with open source, once we ship it, we're tied to that API and we're tied to that functionality for the long haul. So what we've wanted to do is make sure that we've had enough iteration and enough feedback from our user community to be sure that the API is what we want it to be, because we know we're committing to it for years. And we also want to be sure that we've done enough testing to ensure that that open source project is production ready and you can trust your data with it. So even though we're cloud first delivery, we're still committed to open source. It's a core part of what we do. We want to build freely available tools that developers can use to solve their problems related to time series data. All of these components in the center, including things that aren't tied to InfluxDB, are all open source. I think this interoperation of the different pieces and the community interest in those different pieces are what drive the set of capabilities of the entire platform as a whole forward. So as I mentioned, InfluxDB 2.0 has an API that's documented, and it uses the Open API spec, which is previously known as Swagger. So here's a screenshot of our documentation where you can see each resource type, the paths, their arguments, request bodies, and sample responses. So this includes not just, like I said, writing and querying data, but also managing dashboard configurations, users, API access tokens, telegraph configurations, tasks for background processing, monitoring and alerting, checks and notifications, and basically all the configuration information for the platform. The thing that this API enables things like our community templates. So here is a screenshot of the GitHub repo, which is open to the public. and it shows community contributed templates. We've also contributed some of these ourselves, obviously. But templates are collections of dashboards, tasks, checks and notifications, and labels that can be created all at once. Basically, we make it easy to export these things in the UI and then to templates, and then share them with the community through the community templates GitHub repo. And those templates can be applied via command line and soon from within the InfluxDB UI itself. And Johnny will be talking more about that, I believe, tomorrow. So templates work with both InfluxDB 2.0 open source and also InfluxDB cloud. So you can apply them to either one. On our website, we basically have a templates gallery that highlights a couple of the ones that we pulled that we think are noteworthy. Here's, for example, the Apache and Postgres template. So we're pretty excited about that. So the other thing we've done with 2.0 is we have officially supported client libraries. With 1.x, we basically documented the API of InfluxDB and then left it to the community to develop client libraries. Chronograph and Capacitor basically didn't even have client libraries, but they did have APIs that had different levels of documentation. So now we have this API with documentation, and we have client libraries with these languages officially supported: C#, Go, Java, Node, PHP, Python, Ruby, and a bunch more on the way. I believe Rust is going to be the next one. And within the user interface of InfluxDB itself, you can see the basic getting started information for each client library. So here we have the installation and the initialization instructions for the Node.js library. Here we have an example of writing data using the Go library. And then finally, we have an example of executing a query. This is with the PHP library. So each one of the libraries has those three sections, basically setup, write data, query, and we'll be adding more to that over time. So the other thing we're doing is we've recently started working at improving the performance of Flux. As I mentioned, our goal in the beginning was make it work and make it flexible and powerful. Now we're in the stage where we want to work on performance. And the thing is, it's really early on, so there's actually still quite a bit of low-hanging fruit. So we're getting really good performance improvements from this early work. So there's core engine work that's happening, improving the performance of join and drop and keep. Drop and keep are basically functions in Flux that allow you to shape your data so it comes back looking the way you want it to. We have push-down processing, where the Flux engine will push down certain parts of the query to the storage tier. So things like calling a group and then a subsequent count, or a window and then a count, or a group and a window and a count, or a sum and a first on last. Those kinds of things are being worked on right now, and we'll be rolling out in our cloud product first. Some of them are already in production. Some of them are coming over the course of the next 30 days. And the truth is, Flux performance work is going to continue for forever. But right now, the early optimizations are going pretty well. So what are the next steps to actually get to the full release of open source 2.0? So the first big announcement is that we're going to be pulling in InfluxQL. And we'll be pulling in InfluxQL support in addition to basically that query endpoint from 1.x. So that'll be available in Influx Cloud next month, and it will be into the open source before we hit the general release of 2.0 open source. We wanted people to be able to continue to use InfluxQL because many people actually really like it. We're also bringing in the 1.x storage engine. So right now with 2.0, we use the 1.x storage engine, but we use it in a different way than 1.x uses it. And the thing is, initially we thought we had to do that, but we've realized there's another design where we can bring in the 1.x storage engine as is and map it so that users who are upgrading from 1.7 or 1.8 to 2.0 won't have to do a migration of their time series data. And then we're also bringing in the write API from 1.x. The truth is the write API from 2.0 is almost the same. There's just a couple of small differences, but the line protocol is all the same as it is with 1.x. So, but bringing in the right API from 1.x will enable us to offer basically a drop-in upgrade from 1.x to 2.0. Our goal is to make the upgrade experience from, say, 1.7 or 1.8 to 2.0 as seamless as possible. We want it to be as close as the experience is of upgrading, say, from 1.7 to 1.8, which is really, really easy. There's going to be maybe a small thing that's going to have to be done by the operator, but our goal is no big migration, no painful updating of your end client systems. You'll be able to do the upgrade, and then you'll be able to adopt the API and Flux in 2.0 over time. And then obviously we're going to continue working on Flux performance, and we're just continuously doing that basically for forever. So our target is we want to have a 2.0 release of open source in the early fall of this year. So basically within 3 months or so. So then the question is, what's after the GA of open source 2.0? Well, we want to have more Flux connectors. Basically, we want Flux to be able to connect to as many data sources as possible, to either pull data or push data, as many other monitoring and alerting systems as possible. We want it to be integrated with a much broader ecosystem of tools, both closed source and open. Another thing I think is interesting is something that right now I'm calling Flux triggers, but the idea is basically being able to define a Flux script and telling the platform, execute this script when I write data into this bucket. And it could filter, you could filter basically on a measurement to do all sorts of other things. But the idea is whenever you write data, it would write that data to the bucket that you want to be written to, and also evaluate the script and either connect to a third-party system to do some sort of alert, or do some sort of ETL and write it into a different bucket, that kind of stuff. It's basically like a point-by-point thing as data comes flowing in. And the other big thing is streaming Flux. So the way Flux triggers and streaming Flux are different to me, because Flux triggers basically are stateless. As the data comes in, they just do whatever they're going to do. With streaming Flux, the idea is you have a long-running process that keeps some state in memory, so that as things happen, you can update that state and then do other things. User packages is still something we have to get to. So think of like NPM or Ruby gems or Rust cargo crates. We need to have user packages so that people can define their own bits of Flux code and share them either with other people in their organization or with a broader community. And we need to create a package repo for that. So we're going to be getting to that. Another thing we've been thinking about is making it so that you can write tasks in different languages. So the first language we're thinking about supporting for this is Python. So imagine being able to write an arbitrary Python script and telling the platform, this is a task, and it will run that task on some schedule that you define, which can then interact with the entire platform. So we could launch that in cloud, and we could also have rules for the open source system to know how to interact and work with other components. Then there's another bit that I actually want to talk about really briefly, which is Flux usability enhancements. I mentioned like the last part of the development process is basically the make it easy process. Now the truth is we're kind of doing that along the way the whole time, but there's some work that I did earlier this year that Nathaniel Cook and I did. Nathaniel's the lead developer on Flux, where we did a bunch of user research to look at how people were using Flux, what kind of things were tripping them up, and maybe what kind of performance or what improvements we can make to the language that would be additive that might make it a little bit easier to use and a little bit more expressive in terms of basic queries. So I hope everybody can see this, but here's an example from the UI of a basic Flux query. So on the bottom, you have the script where I'm pulling back, data from a bucket. I'm filtering it by a time range. I'm filtering it by a measurement, a field, and a number of different tags. I'm aggregating that data, calling a mean, and then I'm yielding the data. And up top, you can see different tables of data. So when I was doing the user research, one of the things I found was that people frequently got tripped up on the Flux data model, which was essentially a stream of tables, where each table represents a time series. So here in this result set, you can see on the left, we have 3 separate tables, and we're looking at that first table. So with Flux, I wanted to, with basically this new additive addition of Flux, I wanted to be able to maybe simplify the data model so it's a bit easier for people to use, and also simplify some common queries. So for that, let's look at some example data. So this is our basically like NOAA weather data set. This is actually not weather, but it's temperatures taken from rivers and lakes all across the US. So that's our sample data. So here I'm going to show 2 examples. On the top, we have what Flux looks like today, right? So I'm pulling data from the bucket, my data. I'm looking at the last hour. I'm filtering by a measurement and by the field, where the field either should be surface degrees or bottom degrees. I'm grouping all of that together. I'm grabbing the last data point and I'm pivoting it so that it's all together. Actually, I think I should have done the pivot and the last in reverse. And then I'm keeping only the specific columns that I want to keep. So I'm shaping the result set to look like I want it to look. So in this new Flux that you'll be able to opt into once it's available, basically you see the @ sign, which tells it the next thing is going to be a bucket identifier. So at my data, then a dot, and then the next thing is a measurement. So the thing about Flux is we wanted to make it so that you could pull data from all over the database and you could have tags and fields on equal footing. So there was both good and bad. So the good part of that is it makes it much more powerful in terms of working with all the data in your database if you're building like downsampling tasks or like specific kinds of monitoring and alerting. The downside is you lose that organizational unit, which is basically a measurement. A measurement is a core like organizational unit, which is still a concept in InfluxDB 2.0. That's how you write data in. So with this new Flux, what I aimed for was almost everybody's query, like basic queries, always hit a measurement. So I brought that to the forefront here. I made that a first-class citizen. It's basically a requirement as part of this query construction. Then we have the open brackets, braces. We specify which actual columns we want in the result set. So here we want location, we want state, we want surface degrees, we want bottom degrees, and we want time. Now this query by default will just return whatever the last data point was. A single point is what you'll get from that. If we wanted to change that and we wanted to pull back, 3 hours worth of data and aggregate it, it looks like this. So what you can see there on the top line, or in line number 2, is we have essentially filter criteria as the last argument in that brace block, right? So that filter criteria looks very much like a where clause would look in InfluxQL. And then we're calling into an aggregate function. We're saying we want to aggregate the bottom degrees column by the location in 5-minute windows of time. Now, one thing I'm also showing in this example is we'll be adding, right now, all arguments in Flux are named. So you have to specify the name of the argument and then the argument itself. What we'll be doing is we'll be adding the capability to do positional arguments. So here, min, the function definition, defines the first positional argument as whatever the column is that you're going to be aggregating, right? Now, I could also call min with the argument name specified, but I don't have to. I can just use positional arguments, which will make things a little bit more compact and a bit more terse. So here's another example where if we wanted to aggregate multiple columns at the same time, we can do that much, much easier than we could in Flux. In Flux today, what you would have to do is assign the basic data set to some variable, perform the aggregation separately, and then do a join on the result of those 3 aggregations to get them all in the same table. This just does it for you automatically, much faster. And then here's an example of adding the result of adding 2 columns together. So you can call this, say we're adding bottom degrees and top degrees as sum degrees. So again, like you can do all of this currently today with Flux, but the way to construct this query is actually there's a lot more you'd have to type out to get this done. So the goal here was basically to create like a shortcut syntax that makes common queries much easier to express and much faster, while still keeping the functionality for all of what you can do with Flux today. And like I said, this shortcut syntax, when we make it available, will be something that you can opt into. We'll probably make it a default setting for new users coming in. But for people who are previously using Flux the way it is, they'll continue to use it and they'll have to explicitly opt into it if they want to. And that's so that we can make this addition without breaking anybody's code. So this will be an additive change to Flux after the 2.0 release. So the thing I wanted to close with was a little bit of discussion about the core of the database. I mentioned that InfluxDB 2.0 is about unifying the stack, and it's about drastically improving the functionality of the platform through Flux. But the truth is, what we haven't really focused on over the last few years is we haven't focused on the core storage capability of the database. So we've recently started doing research into some improvements we can make to the DB, and we're hoping to land these things next year. So these are basically goals that we have for core database improvements next year. The first one, and it's the one that I'm probably the most excited about, is we want to be able to support infinite cardinality, right? Right now, when you write data in and you have your tags, you always have to be concerned about what the cardinality of that data is. We want infinite cardinality. Now, the truth is, like with TSI, the time series indexing stuff that we have, you can actually get pretty high cardinality in the database, but the problem is you can't query that data all together, right? To query across 1 million time series is basically just not possible at this stage. So we want infinite cardinality both in the ingest side and in the query side. And I think that's really interesting because it'll enable all sorts of things like tracing, behavioral analytics, all sorts of different analytics, more fine-grained control over what you can store in terms of like process monitoring, network monitoring, all that kind of stuff that usually results in really high cardinality data. Tiered data storage is another big one. So the way I'm thinking about the tiers of data is essentially you have in-memory, you have locally attached SSD, and then you have object storage, which is probably backed by spinning disk that's over a network. So we want the database to be able to manage this data lifecycle in tiered data storage so that you have, the hot data that you're querying constantly in memory while it's constantly moving data in and out of object storage automatically for you, so that it's, much more cost effective to keep all your data for all time, for example. And it will also allow us to scale the size of an individual database to basically whatever an object store will support, which is, petabytes are essentially infinite. We're also looking at improvements we can make to the core query performance, right? And I say like core query performance because, like I said, Flux it's a combination of scripting language and, query language. The storage piece, for us is basically the core like declarative query functionality or the basic like aggregations, grouping, windowing, that kind of stuff. So we think we can get some really good improvements in the core query performance of the storage tier that will enable faster performance for Flux itself. Real-time subscriptions is a big one. With time series data, I think it's obviously important to store and query that data, but it's also important to be able to monitor that data in real time so that you can do ETL, you can monitor and alert on it. So I think subscription supported at the database level where you can say, I want to subscribe to this measurement and this bucket with matching this predicate. And we want to enable that. And lastly, we want operators of the database to be able to define arbitrary replication topologies. And the replication will be both push or pull, at least that's a goal. And basically you'll be able to say, this data should be replicated to this server or this place. These queries should be proxied over here. And you'll be able to define those things differently for each individual server. So you can create any sort of cluster topology that you can think of. So that's it. That's the stuff that we have coming, and please look for the 2.0 general release later this year, and I'll be more than happy to answer questions in Slack. Thank you.
Thank you, Paul. But before you go, so I mentioned that we are giving away swag, and Paul came up with 3 questions that he would like you guys to answer, and you guys can answer it in the community Slack. So so before I ask these questions that Paul so kindly gave us, if you do have any questions for Paul, please post your questions in the Q&A or the chat or the Slack channel, whatever is convenient for you. I already have a huge list, and I hope we can get through a lot of them. But I think Michael Hall said it the best. I think every time there was a question, Paul, you were absolutely on point. The question was asked, and then in your presentation, you answered it. So I think we'll be able to get through a lot of these questions really quickly. But please feel free to post your questions so we can have Mr. Paul answer them for you. All right, so question number 1. What year was the first release of InfluxDB? Question number 2. Name 3 languages officially supported by the client libraries for InfluxDB 2.0. And the third one is, what open source license does InfluxDB use? So we'll post those questions in the chat so you guys can answer them. And Jesse is helping to make sure that we get the people who put the right answers, and the lucky winners will be able to get a really cool t-shirt. So Jesse, if you don't mind posting that. All right, so let's go down to some of the questions that we have. Let's just start from the top. So Farrick has asked a couple of times, we are using 1.x, but they couldn't find documentation about migration from 1x to 2.0. I know you mentioned this, but maybe you can just reiterate just for the audience about the migration plans.
The migration plans to 2.0?
Yep.
Yeah, so so basically the 2.0 database looks like essentially there's 2 different data stores within 2.0. There's the raw time series data storage. Now, when a user upgrades from 1.8 to 2.0, that raw time series data storage won't need to be touched. It'll just exist as it is, which was going to be like the most difficult part of the upgrade. Then the other piece in 2.0 is essentially a BoltDB embedded database that stores all the metadata, like what users, what API tokens, what tasks, all this other stuff. So that is the one thing that will basically need to be created as you upgrade. So like I said, our goal is that you'll be able to upgrade by maybe specifying like 1 piece of information or 2, and then do that. From an API perspective, 2.0 will support the 1.x API. So basically, if you have a bunch of clients or you have Grafana or whatever using the 1.x API, you'll be able to upgrade to 2.0. They'll still be able to talk to it just as though it were a 1.x server. And then over time, you can upgrade those clients, right? You can adopt our 2.0 client libraries. We're working with the Grafana team to have Grafana officially support the 2.0 API. There'll be more about that, I think, whenever the Grafana talk is, maybe tomorrow. So like I said, the goal really is an in-place upgrade that looks very much like 1.7 to 1.8. And then you'll be able to, transition over time so you don't have to try and like upgrade everything all at once.
Perfect. All right, so Raphael asks, the Prometheus remote write, remote read features will be available in 2.0?
Sorry, what was that?
So Raphael was asking, he wanted to know if the Prometheus remote write, remote read features will be available in 2.0.
So not at release, but we want to be able to support the Prometheus remote write API for sure. Remote read, we're unlikely to support that, mainly because to my knowledge, nobody actually uses that, even within the Prometheus ecosystem. What people have done instead is they've imported the Prometheus, basically, query engine into their projects and then supported PromQL as just a native way to do things. That's definitely something that we're evaluating. It's certainly something we could do for our cloud product, fairly much easier than other products. Basically, create the Prometheus query service as a separate service, and then just connect it to our storage tier. We could probably get pretty good performance out of that. That's actually what we ended up doing with InfluxQL. As some of you may know, originally what we were trying to do is we were trying to build a transpiler that would transpile InfluxQL into Flux and then execute it. That effort may still happen, or we had already gone pretty far down that path. But what we found was that it was much, much faster for us to just take the InfluxQL parser and query engine as is and wrap it in a service and then deploy that as a service into our cloud product, which is how we're supporting InfluxQL in cloud. That's probably the same thing we do with Prometheus if we're going to support the PromQL as a language, which again, like I said, InfluxDB is a platform. We want it to be multi-language. We don't want to force people to use Flux if they don't want to use Flux. We want people to use the tool that they want to use. It's just a matter of when we can get to that if we can.
Awesome. So Raphael, just let us know, or let Paul know if you have any other follow-up questions to that. So there were a number of questions about capacitor. Is capacitor no longer a key product? Will it be deprecated? What about the future support for capacitor? Can you touch upon that a little bit more?
Yeah, it's a good question. I should have covered this in my talk. We're going to continue to support capacitor, and we're going to make updates for it. And we're going to make updates for it so that it will interact with 2.0. Now, at 2.0 general release, capacitor, if you're using batch tick scripts, will be able to just work with 2.0 as is. If you're using streaming and you're writing your data directly into capacitor, again, it'll work with 2.0 and you'll be fine. The one thing that won't be there at launch is the subscription functionality. So that's something that we have to figure out how to address. But with capacitor, we realized that a lot of people have invested, time into writing tick scripts. So we want to continue to support it. And that will continue to live on basically as just as open source software.
Excellent. Just a couple more. How about the security and data encryption in InfluxDB 2.0?
So we do encryption, in flight. If you want to encrypt your data at rest, at this point, it's use an encrypted file system. We don't actually do encryption within the database itself. The way the 2.0 open source will map data under the covers is essentially like a bucket and a database and a replication policy together represent a bucket. So what that means is data for any given bucket is segregated into their own separate files. So you'd have to encrypt, using your file system or whatever.
Okay, so Siam, if you have any more questions on that, I think you found some documentation on that as well. So Chorang asked, what about the enterprise version? What are the plans for that?
So for Enterprise 1.x, we're going to continue to do point releases along the way. We're going to have better and better Flux support within Enterprise 1.x. These performance improvements will be landing in 1.x, obviously after our cloud product. For 2.0, Enterprise is not scheduled anytime this year. We're going to be working on that for, I'd say the latter half of next year. But in the interim, we're going to continue to develop the 1.x Enterprise product so that many of these 2.0 enhancements will be landing there.
Awesome. What's the timeline for a Rust client library for InfluxDB 2.0 open source?
Oh, that one I actually don't know. I would assume it's coming within the next 30 days or so, but I actually don't know.
I think I saw somewhere that it is definitely a work in progress. Let's see, let's just do a couple more and then we'll just hand all these questions to Paul and he can answer them in the channel. So we have a nice collection for you, Paul, to make it easy for you. Let's see. How does a customer requiring on-prem storage use 2.0? Is there a 2.0 enterprise version or only cloud?
Yeah, so yeah, so for 2.0 right now and for probably the next 12 months, you're limited to either the open source build or a cloud product. We don't have an enterprise 2.0 product, but we will have an enterprise 2.0 product later for people who require on-prem. Now, one thing we can do with our cloud product is we will be launching essentially like bring your own. So we can do a managed cloud service in a VPC that you define, an area you define for us to use, so that we can operate essentially our cloud product in your environment in like a firewalled off area of your environment. So if you're in one of the public clouds, that will be an option well in advance of Enterprise 2.0.
All right, we'll end with a real fun one. So Pierre Luigi asks, will there be any technologies or techniques to achieve HA in the open source version of InfluxDB 2.0?
So our goal is to have as much as possible in the open source. And right now, my plan is to have that replication stuff that I talked about in the open source build of InfluxDB 2, in the new storage tier.
Awesome. That must feel good to say that after all this time. All right, I know there are a ton more questions, and like I mentioned, we pulled all the questions out of the various Slack channels, the Zoom Q&A, and the chat. Make it easy for Paul to be able to answer all these, and we'll just populate all the Q&A in one go in the Slack channel for everybody. So Paul, thank you so much. And I'm sure everyone's going to look forward to chatting with you in the Slack channel. So thank you.
Thanks.